Hello everyone, this is Akshmala and I will take you through AIET 6 Class 12 NEET paper solution. Okay, so I have included some questions, not all, because some questions were very basic, like directly from formula. You just needed to have formula in your hand to solve those questions. But yes, I have taken those questions for discussion, which I feel like you may have got stuck in those or those questions where I felt like I need to give some concept. Okay. And also I've included some questions that was somewhat wrongly informed. So, okay, no worries. We will go ahead with our very first question. And the very first question is question number one of your question paper. Okay. So I hope you all must have done this question. And this is a very important topic actually. And this question is based on a formula, and that is called potential gradient. And this you should remember because question from this person is going to come. Okay. So you should have this formula in your head. And what is that formula? Electric field. How you will calculate electric field if voltage or potential is given as a function of space. Okay. So we write electric field as d by dx of v I cap plus d by dy v j cap plus dy dz v k cap. Okay. And what is one important thing while using this formula? That is when we will be differentiating voltage with respect to x, we will be considering y and z as constant. And similarly, this thing will translate to other things also, like if we have to go for dv by dy, so when we are differentiating voltage with respect to y, we will be considering here x and z as constant, and here x and y as constant. Okay. So now let's calculate it. Electric field value. Electric field value will be how much? V is given as a function of uh, x coordinate, that is v equal to 3x square. So if you are going to put here dy dx of v का value आप put कर दो, that is 3x square I cap plus d by dy 3x square j cap plus dy dz 3x square k cap. Now 3x square का differentiation with respect to x will be how much? It will be 6x I cap plus. Now, as I said just now, if when you are differentiating with respect to y, consider x and z as constant. So here 3 is constant. X will also be treated as constant here because we are differentiating it with respect to y. So ये 0 हो गया. Similarly, this is also 0. Done. So electric field is only in the I direction, that is x direction. Okay. And its value is how much? 6x I cap. Now, we have to calculate electric field at this point. This point means x equal to 1, y equal to 0, z equal to 3. So if you're going to put the value of electric field at this point, x value you will keep as 1. So this will become 6 I cap. So 6 I cap. Sorry, here in the formula I've done one mistake, that is E equal to this potential gradient तो आप लिखोगे with negative sign. ठीक है, यहाँ पे नेगेटिव साइन होता है क्योंकि यू जस्ट रिमेंबर दैट फॉर्मूला dv इक्वल टू माइनस e डॉट dl. We write like this. ठीक है, so negative signs should have been here. I forgot to keep it. So this is minus, and here also it will be minus. So this is minus 6i. Okay, so electric field is not in x direction, rather it is in minus x direction. So 6 volt per meter directed along negative x-axis. Done. So D is the correct answer. I hope it is clear. Now, let's move on to the next question. So this is a Rutherford experiment question, and this topic I have not taught in the class, but still, even if you remember this Rutherford experiment that you studied in class 9th or 10th, sorry, in class 10th, you must have studied in chemistry. Done. So in Rutherford experiment, like a structure of atom, whenever you were reading, I guess in class 9 chemistry, okay. So we have learned that what happens, most of the space inside atom is empty. Most of the space is what? Empty. And inside atom there is just a region, and this region has very strong mass, and this is nucleus, right? So in Rutherford experiment also, most of the alpha particles went undeviated. Why? Because most of the space was empty. Most of them went undeviated, and whatever was going closer to the nucleus was getting deviated by certain angle, and what was going just straight towards the nucleus got retraced. Okay? So here theta is a scattering angle. So for most of the alpha particle, scattering angle theta is 0 because it's going undeviated. Done. And very few alpha particles will have angle of scattering 180 degree. Okay? So this is for maximum, and this is for very less number of particle, very less. Okay? Done hai. Y is number of scattered alpha particle detected. Now, if you draw the graph of y versus theta, so for theta equal to 0 degree, you will get maximum value of y. So here theta 0, y is 0. This is not correct. Here also when theta is 0, y is 0. This is also not correct. And here when theta is 0, y is certain number of values, some finite value, right? And see here, when this graph is approaching theta equal to 0, it is approaching y equal to infinity, yani ki some large number of values. So this graph will be correct, not this. This will be correct. Because for theta equal to 0, you see here, for theta equal to 0, y for theta equal to 0, y is tending to infinity, and for theta equal to pi degree. Okay? So for theta equal to 180 degree, what is the value of y? It is almost tending to 0. So y in that case is tending to 0, and uh, that is in sequence with, or that is in agreement with Rutherford Goldfoil experiment. So this will be your what? Correct. Okay. Chalo. So this was a very easy question. Again, you just needed to go through the facts. And this fact, we know since our class 9. We don't need to read it in advance. Chalo. This is a question from class 11th. And this is from your equipartition of energy. That is, if there is an atom or molecule at certain temperature T, it will have certain energy and certain degree of freedom. Done. So we have studied that if gas is monoatomic, no matter what the temperature is, it will have 3 degree of freedom, and that is translation. Kyunki this is a monoatomic single atom, it can only translate, it can't rotate. Okay, so it has only translational degree of freedom. Now, if this is diatomic, so in case of diatomic, we have studied that 3 translational degree of freedom, 2 rotational degree of freedom, plus some vibrational degree of freedom it can have depending on its temperature is high or low. If temperature is low, no vibrational mode. If temperature is taken into account, then vibrational mode will come. Otherwise, we just say this is diatomic has 5 degree of freedom, 3 translation, 2 rotation. Okay. Now come to the triatomic molecule. Triatomic में आप लोग पढ़े होंगे. In triatomic, there are 2 cases. That is, if the molecule shape is linear, then it will have a degree of freedom same as diatomic gases. That is 3 translational plus 2 rotational. But if this is non-linear, and in case of non-linear, it will have 3 translation plus 3 rotation. Okay. Now let's do the match column. 3 translational degree of freedom. So it will be what? Monoatomic gases. So 1. A का क्या होगा? A का होगा 1. So A की जगह आप क्या लिख लो? 1 लिख. Second में आते 3 translational, 2 rotational degree of freedom. So this is definitely non-rigid diatomic gases. और क्या होगा ये? 3 translational, 2 rotational degree of freedom. So what should be the answer? B का आंसर शुड बी रिजिड डायटोमिक गैसेस. देखो यहाँ पे नॉन रिजिड डायटोमिक गैस है, rigid diatomic gases. ठीक है, so one might get confused in these two, rigid and non-rigid. So whatever degree of freedom we have studied, that is for rigid diatomic gases. Okay, that is for rigid thing. Done. So B का आंसर क्या होना चाहिए, rigid diatomic gases या non-rigid diatomic gases? This is for rigid diatomic gases. Done. So for B, answer should be your C. Now come to the third. There is error here in the question. 3 translational and here it is 2 rotational. That is why I included this question. Okay. So you see here 3 translational, 2 rotational and 1 vibrational degree of freedom. Okay. So since in the question there is no talk of linear or non-linear gases, linear or non-linear polyatomic gases. So if it has 3 translational and 2 rotational degree of freedom, it means it is what? It is your it is what? 3 translational, 2 rotational, 1 vibrational degree of freedom. So it will its correct option will be what? Let me know. What will be the answer for C? So for C, answer will be, see here, generally in diatomic gases, their vibrational mode is not excited. Okay, vibrational mode get excited at high temperature, very high temperature, but here there is no talk of high temperature. Done. And if there is no talk of high temperature, still vibrational degree of freedom is getting initiated. It means whatever gas we are talking about, this is not rigid. If it is rigid, it will have no vibrational degree of freedom in general. Okay. So if it is having 3 translational, 2 rotational, and 1 vibrational degree of freedom, we can say this is non-rigid diatomic gas. So for C, we will take what? We will take 4. Okay, why I took 4? This is non-rigid, so it can have vibrational degree of freedom in general. क्योंकि देखो vibrational mode, when does it come? It comes when something starts vibrating, and if something is rigid, it won't vibrate at low temperature or even at normal temperature. It requires high temperature to vibrate. Done. But if something is non-rigid, it can vibrate at low temperature, at normal temperature, right? And that is why I'm taking that. Okay, so don't get confused in that. Now let's come to another one. Last one, 3 translational, 3 rotational, and more than 1 vibrational degree of freedom. So given 3 translational, 3 rotational, it will be polyatomic gases. Done. So here polyatomic option is only one, that is 2. Done. So correct answer for D will be what? It will be 2. So which one is going to be correct? Correct will be A1, B, 3. So this is C. Done. And in D, if you see carefully, only option B and C are getting swapped. Done. So we need to have a concept of rigid and non-rigid gases. Okay? If gas is rigid, it won't exhibit vibrational mode at normal temperature. Okay. So this thing you keep in your head. And that is why I included this question. Okay. So correct option is C. Now let's move on to next question. Kinetic energy of an electron, alpha particle and proton are given this much of energies. De Broglie wavelength and de Broglie wavelength relation will look like what? That is the question, right? So what is de Broglie wavelength? It is lambda equal to h by p. H is Planck's constant, p is momentum of that particle. You know? So here momentum is not given, kinetic energy is given. And from kinetic energy, we can easily calculate what? Momentum. So momentum can be written as root under 2mk, where m is the mass of particle, k is kinetic energy. So यहाँ अब इसको derive करने की जरूरत नहीं है. Half mv square equal to k से you can calculate this relation. Okay. So you just see here h by root under 2mk. We have 3 particles, right? We have 3 particles. One is electron, another is your alpha particle, and third one is your proton. Now carefully see here, electron is given kinetic energy 4k. This is given kinetic energy of 2k, and this is given kinetic energy of k. Mass of electron is of range of what? 9.31 into 10 to the power minus 31 kg. Okay? And mass of proton, if you see, this is 1.67 into 10 to the power minus 27. Okay? So electron is how much times lighter? It is 10 to the power 4 times lighter. So mass of electron is too much less than that of proton. Mass of alpha particle, 4 into mass of proton. Okay. So these two masses are comparable. Another is 4 times that of proton, but these two masses are not comparable because electrons mass is 10 to the power 4 times less. So what is significance of this? You see here, lambda of electron, if I calculate, so I will write h by 2mk, and kinetic energy is 4k, whatever it is. Here mass of electron, like lambda e, agar aap dekho, this is directly proportional to what? 1 by root under m. Done. So it's inversely proportional to mass. And if mass is smaller, wave, the Broglie wavelength will be higher. And mass of electron is very, very, very much smaller. That much smaller that its value of lambda won't much depend on the relation of kinetic energy given here, because here kinetic energy is quite comparable of each particles, but mass of electron is not comparable with these two. So mass of the electron will guide its de Broglie wavelength relation that we have to establish here. So its mass is 10 to the power 4 times smaller, so its de Broglie wavelength will be much, much higher than that of alpha particle and that of proton. So सबसे ज़्यादा de Broglie wavelength will be for what? For electron. Done. So lambda E has to be highest. One relation we got. Now, what about alpha particle and P? So proton, let's calculate that now. So if you're going to write lambda of alpha particle by lambda of proton, and I will write here mass of proton, kinetic energy of proton root under by mass of alpha particle, kinetic energy of proton. So mass of proton को वैसे ही रहने दो. Kinetic energy of proton is K. Mass of alpha particle is 4 into this. And kinetic energy of alpha particle is 2. ठीक है? कुछ ऐसा आ रहा है. So lambda alpha by lambda p. If you are going to cancel everything, 1 by 8. So this is lambda alpha by lambda p equal to 1 by root under 8. So lambda of p is root 8 times lambda of alpha. So first, lambda of electron is the highest. उसके बाद which one will have a more greater de Broglie wavelength? That is your proton. Done. So trend should be what? Lambda E is greater than lambda P is greater than lambda alpha. This is the correct answer. So here things are lambda alpha greater than lambda P. नहीं, कोई भी equal नहीं है. So ये गलत हुआ, ये भी गलत हुआ, कोई भी equal नहीं है. This is correct, right? This is written in what? Decreasing order. This is written in increasing order. So both are the same, right? So this is your correct. Okay. Chalo. Yes, this question. So in this question, actually, what we need to do, how we solve such question. You just see here what is given. There is a plate like this, and this point is B, and there is a plate like this, its point is A, and then there is another plate S. ठीक है. So ये नाम मैंने पहले से लिख रखा था. Let it not be there for now. How you solve this question? Like these are the plates of capacitor. Can you just by looking at the diagram say ki which plates are in series, which in parallel? A bit difficult, right? If you're not into practice and if you don't know the tricks. So what you need to do is, first thing that you should bear in your head is identify plates with different potentials. Okay, so this is point B, and from point B this whole thing is coming out. Done. So this plate will have same potential as this plate, and its potential will be equal to potential of B. So with potential B we have these two plates, or whatever, this whole will have the potential same as B. Done. Similarly, here there is another thing like this, and throughout potential will remain same because this is a conducting thing. So potential on the surface will remain constant throughout. Let's say potential here is C. So throughout potential will remain C. So in terms of potential, we got another point that is C. So C को आप कहीं यहाँ पे रख लो. Now, so all plates we have dealt with. One more is left, that is this. And it is connected directly to point A. So its potential will be same as that of point A. Point A भी एक मिला हमें potential के term में. So in terms of different potentials, how many points we are getting? B, C, A. ठीक है? Now what you do? Now you try to see between B and C. यानी कि between potential VB and VC, or you can say how many plates of potential VB will face plates with potential VC. मेरे कहने का मतलब यहाँ पे ये है, you just try to see here, this B is facing with this C. Done. So these two will make one capacitor between B and C. So between B and C, join one capacitor. Okay. Again, this C and this B. Again, one more pair of plates. So between B and C, one more. So one more आप यहाँ पे लिख दो. Now, this and this are making one capacitor. This is in terms of potential B, and this is in terms of potential A. So between B and A, one plate. ठीक है? अब आप ऐसे connect कर दो. Now this and this is making another capacitor. This is A and this is C in terms of potential. So between A and C, another. So this is like this. And between A and B, we have to calculate potential. Sorry, capacitance. So you just see here, what is this? This two is in parallel. This is C, this is C. So this will become 2C. Okay. So this system will look like this. This, okay. And here is the point A, here is the point B. So between A and B, what potential difference we are going to get? We are going to get 2C, C are in series. So 2C into C by 3C. And this is equal to how much? 2C by 3. And this 2C by 3 is in parallel with C. So C equivalent will be 2C by 3 plus C. And this is equal to 5C by 3. So this will be your answer. 5 by 3, C का value क्या लिखोगे? Epsilon naught A by D. Because each plate has an area of A, and separation between two consecutive plate is given. All two consecutive plate is D, and medium is vacuum. So epsilon naught A by D. Yes, no correct option is no correct answer is available there in your option. That was the mistake in this question. So correct answer will be what? 5 by 3 epsilon naught A by D. And that is why I picked this question, to make it clear that whatever solution, whatever option is given is not having correct answer. Okay. I hope it is clear. So in this next question, let's see what is given. And an object undergoing SHM takes 0.5 seconds to travel from one point of zero velocity to next such point. Okay. So this is a question from SHM. That is, in SHM, we know that there are 3 points basically, and 3 technical points, and one is called your mean point. Done. And another is your extreme, and also there are 2 extremes. So 2 extremes and 1 mean. Mean and extreme are equally spaced. I mean, distance between this extreme and mean is same as distance between mean and this extreme. Okay, so they are equally spaced. Another thing, what we have learned is, if we are talking about a normal SHM that we have studied, in that case, at mean position, what will happen? Velocity will be maximum. Okay, and acceleration will become equal to 0. And here velocity will be 0, and the displacement is maximum, because this is the point of amplitude actually. So here also x is 0. Mean, if we are taking as origin, if our particle is starting from the mean position, this is x equal to 0. Okay. or take mean. You can always take mean as origin. Okay, so this is x equal to 0 and here x equal to amplitude. Okay, so this is the simplest case of SHM diagram that we read. And here also, similarly, velocity will be 0 and amplitude will be maximum. Also, acceleration here will be maximum at extremes. Now let's read the question. So an object undergoing SHM takes 0.5 seconds to travel from one point of zero velocity to the next such point. Yani ki half second it is taking, suppose my particle is here, okay? And half second it is taking from reaching to this place. Yani ki it's starting from here to here. So from here to here, it is taking how much time? It is taking half second. Okay. The distance between those points is 50 centimeters. So this whole distance is given as 50 centimeters. And since mean and extremes are equally spaced both sides, this small distance will become how much? 25 centimeter, and this is equal to amplitude. Done. So amplitude value is how much? 25 centimeter. Time period निकालना है, frequency निकालनी है, and amplitude. So what will be the time period? So one time period means what? So if our particle, one time period means it is reaching at the same point from which it is, or from where it started, right? So suppose my particle started from here, and that is here at from extreme, from one extreme it started. So it is moving towards this. First, it will reach the mean position, then it will go here to another extreme, and वापस it will go here like this and then reach here. So this will be counted as one time period. And in the question, it is given that from time it takes to reach or to travel from A to B is what? Half second. So from B to A, it also be what? Half second. Symmetry, we can see half second, right? Done. So total time period, if we talk about, will be how much? Time period will become 2 into half. Because half second it is taking from traveling A to B. And traveling back to A, it will take another half second and that will constitute time period. So 2 into half. So the answer will be how much? 1 second. So time period is 1 second. Frequency kya hota hai? 1 by time period. So that will also become 1 hertz. SI unit of frequency is hertz. SI unit when you are taking time in second. Okay. So 1 by 1 second. And this is equal to 1 hertz. And that is how we'll reach up to answer. But this is looking very simple, and still I included this question because I want to say you here one thing, that what I used here in the question, I said that if my particle is starting from point A and it is reaching B in half second, then time it will take to travel from B to A will also be half second. So I'm saying in upward journey towards B, if it is taking half second, then in journey towards A, it will also take half second. So kind of unitary method I have used, right? But be careful. जैसे यहाँ पे I have said that half journey it is covering in half second. So full journey it will cover in 1 second. And that is why time period is 1 second. But if in some question it is given like that, you are starting from, suppose kar lo, from 1/4 of the path, 1/4 of the amplitude. So this is equal to amplitude, this is 0. And suppose particle is starting from A by 4. Okay? And no, चलो मैं और भी इजी करती हूँ इस चीज को. सपोज कर लो अगेन इन दिस केस ऑल्सो माई पार्टिकल इज स्टार्टिंग फ्रॉम ए. ठीक है, इट इज स्टार्टिंग फ्रॉम ए and it is reaching to B in half second. Same question, but if it is asked that how much time it will take to reach from this point to this point, and these 2 points are spaced at A by 2, suppose half. So will you do like it is taking like half second in reaching here, then 1/4 second in reaching here, then half of 1/4 second in reaching here? Will you go on like this? Don't go like this. Don't use such unitary method for small intervals. Unitary method you can go if it is asked about time period. If it is given that distance or time taken to reach to one extreme from another extreme or from mean to extreme is given. Suppose kar lo in question it is given that time taken by particle to move from mean to extreme is half second. Then tell the time period. So that will become 4 into half second. But if it is given that from mean to extreme it is going in half second, then how much time it will take to go from mean to a by 2? So will you say 1 by 4 second? No, this won't be correct. In that case, you need to solve. And how we solve? SHM ka equation, if it is starting from mean, x equal to a sin omega t. So properly you put x का value आप क्या put करोगे? यहाँ तक पहुंचने का मतलब x कितना हो गया? a by 2. So this is a sine omega t, and this is half. So sine 6 sine 30, that is pi by 6 equal to sine omega t. So this is your pi by 6. मैं क्यों कर रही हूँ? I will let you know. And the time period is equal to what? 2 pi by omega. So omega is equal to 2 pi by t into t. So you see here, this is equal to how much? T by 12 time period. So this is not equal to t by like time period whole is, if time period is t, then this is by unitary method. This is t by 8, you can say. Done? Or whatever. But answer you won't get like that. Okay. So don't go with unitary method for all the intervals. Always opt for calculation. Done? When we can go with unitary method when like when it is given that from mean to extreme this much time it is taking, or from one extreme to another it is taking this much time, then what will be the time period? So in that case you can go, but if you have to calculate time taken from one point to another point in SHM, don't go with unitary method. You okay? Directly use the equations and calculate. Done. I hope it is clear. And here I directly used unitary method because from one extreme to another extreme time is given. So from again that extreme to another one, half second hi lagega. There is so much symmetry here. That is why I used. Again, here also you can use equation and you will get the same answer. Okay, so now this is the question. ABC is an equilateral triangle. Charge plus Q are placed at each corner as shown in the figure. Electric intensity at center O will be. Again, why I included this question? You just see here. Electric field because of plus Q charge at this point will be in this sense. Okay? And because of plus Q charge will be in this sense. And because of this plus Q will be in this sense. And magnitude will be same because this is R, this is R, this is R. Magnitude because of any charge at magnitude of electric field because of any charge at the centroid, at the center of triangle will be kq by r square. So magnitude is same, and angle between these two will be 120, this to 120, this to 120. So we are given three vectors with angle 120 in between them. Okay, what will be the result? So resultant will be 0 because we have learned that if vectors are equal and angle between them is 120, three vectors I'm talking about. Like if there are two vectors, जैसे suppose कर लो, we have two vectors and they are at an angle 120 degree. They are equal vectors. So A, इन दोनों का resultant अगर आप निकालोगे, so put the formula A का square, vector 1 का magnitude, vector 2 का magnitude, 2 into vector A, vector B, cos 120. And cos 120 का value क्या होता है? Minus half. So this will become a square plus a square minus 2a not minus a square, because 2a square into minus half, so this will remain minus a square. So this is a square and a. So resultant of two vectors at 120 degrees is how much? A. And since these are two equal vectors, their resultant will pass through angle bisector, so it will go through 60 degrees. Same thing you apply here. So suppose I'm taking any two electric field. Suppose this one and this one I'm taking. So their resultant will pass through this. And it will pass along the angle bisector. So this will make 60 degree with this. And its magnitude will be equal to E. If this is E, this is E. And since they are at 120 degrees, their magnitude will be equal to E, and their vector will pass through the angle bisector. Now you can see this is also E. And resultant of these two is also E. Finally, you have to add these three. So addition of this is this. So this plus this will become equal to what? 0. So always remember that if you're given two vectors at 120 degree, their resultant will be equal to any of that one vector passing through angle bisector. And if there are three equal vectors at 120 degree, their resultant will always be 0. Mind it, mind that vectors magnitude has to be equal. अगर equal नहीं है तो resultant 0 नहीं होगा. ठीक है, चलो. So correct answer will be D. Now this is the question. There is a rough vertical board and this has an acceleration A along the horizontal so that block of mass M pressing against it does not fall. So this is not falling, right? The coefficient of friction between block and the board is done. So if this is not falling and this hole is going forward with acceleration A, this mass also has acceleration A. So I'm going to write the ABD of M. This has acceleration how much? A. Now start writing force acting on it. So mg will act downward and it is resting on a surface. This surface has friction. So this mass has tendency of falling down. So friction will act in the upward direction, opposite to the tendency of fall, that is friction in this direction. Now in this direction, this mass will press this rectangular thing in this direction. Done. And reaction force will act in this direction on capital mass N. So this is the normal reaction. So normal force on this is equal to N. Now this particle is moving forward with acceleration A. So horizontal force would be equal to mass into acceleration. So horizontal force is only N and this would be equal to M. Done. And your friction can be what? This friction can be maximum, can be less than maximum, right? So friction will be less than equal to mu n. Done. And here friction less than equal to mu n का value आप रख दो. ठीक है? So and here since this is not falling down also, friction will be equal to what? Mg. So if we equation in horizontal direction, if you deal with horizontal direction, it has acceleration A. So all horizontal force will add up to mass into acceleration. So this is first equation. In vertical direction, it has no motion. So friction force will be equal to mg. Now this is this. अब आप एक काम करो, values को put करो. Why I wrote this? Friction will be less than equal to mu n. I know it may be maximum, it may be less than that. Now friction is equal to how much? mg. So mg less than equal to mu n का value क्या रखोगे? ma. So m got cancelled. G is less than equal to g by a less than equal to mu. So mu is greater than equal to g by a. So which option will be correct? Mu is greater than a by g? No. Mu is less than g by a? No. Mu is equal to a by g? No. Mu can be equal to g by a. So mu is greater than g by a? Yes. It can be. So answer can be mu equal to g by a. Yeah, mu is greater than g by a. This option is not given. This is given. So this is correct. Okay. Chalo. Now this is the question. There is a plane wave of wavelength 6250 angstrom. And this is incident normally on a slit of width this much. The width of principal maxima on a screen distant 50 centimeter will be. So it's only talking about a slit. A slit is there. So there is a single slit. Yani ki this is a question of diffraction. And in diffraction, we know that what happens? Central maxima will be there. And this central maxima will have a certain width. I'm weak at diagram, but I will draw it for you. So this is the width of central maxima. Okay. And just give me 1 second. Yes. So here you can see what? Here there is a light in this region and here first minima we are encountering. We have to say what is the width of central maxima. Okay. So Which width they are talking about? This much. Again, this width and this width will be equal. In diagram, it's not looking like that, but that is why I'm informing you. This are equal. So around the central line, it will be symmetrical. Okay. And we have learned in diffraction that for minima, a sine theta, where a is this and theta is what? Suppose here we are getting minima now. So you draw the line like this. So here theta. Here we are getting first minima. Let's say this angle is theta. Then a sine theta will be equal to lambda. For first minima, n, generally this is a sine theta equal to n lambda. For first minima, n will become equal to lambda. So here generally, if nothing is given in the question, so we will assume that this theta is very small. Done. So a theta, sine theta will become equal to theta, lambda theta equal to lambda by a. Okay. So this angle is lambda by a. Again, this side also, it first minima will be at the same angle. So this is also theta. So what is the angular width of this maxima? Because here first minima, here this side first minima is here, and in between these 2 points there is maxima. Yani ki in angle 2 theta, maxima is contained, central maxima is contained. So angular width of this central maxima is how much? अगर क्वेश्चन में एंगुलर विथ पूछ रहा है, so angular width will be equal to 2 theta, and 2 into theta is equal to lambda by a. How we will calculate the linear width? That is this. Okay, how we do this? So if you have angular width with yourself and theta is small as we have assumed, in that case y will be equal to theta into d, where d is this. Okay. So our answer will be 2 into lambda by a into d. Now let's put the values. So 2 into lambda is how much? It is 6250 angstrom 10 to the power minus 10 divided by a. A is how much? 2 into 10 to the power minus 2 centimeter. So this will become minus 4 meter. Okay. 2 lambda by a into d. And this is 50 centimeter, means half meter. Okay, so this is 2, 2. And this will become how much? This is 10, 10 to the power minus 9. And this is minus 4, so 10 to the power minus 5. And divide this thing. So 6 to 5 by 2 kar do aap. So you will get how much? You will get something like this into 10 to the power minus 5 meter. Okay. This is 10 to the power minus 5 meter. Now this option in meter is 10 to the power minus 3. So this is not correct. Then so let's convert it into centimeter. So if you're going to convert it into centimeter, into 100 karenge. And if you're going to do into 100, this will become 10 to the power minus 3. So 312.5 into 10 to the power minus 3 centimeter. This will be your correct answer. Again, this explanation you keep in your head. Okay. Okay, sorry. Yes. Now this is a very important topic because from here question comes time and again. So there are two isolated conducting sphere. We have S1, we have S2. They are isolated. Its radius is 2 by 3r. Its radius is r by 3. Okay? And one has a charge of 12 microcoulomb. This has a charge of 12 microcoulomb and this has a charge of minus 3 microcoulomb. Okay? And are at a large distance from each other. They are now connected by a conducting wire. A long time after this is done, after connection is made, charge on S1 and S2 are respectively what? Okay. So they are an isolated system. Initially, they are isolated. They are not connected. And also they are not connected to any other source. So they are isolated. Done. And finally, connection is made. Now, what will happen after connection is made? So before connection was made, before let's say this is a sphere A, this is a sphere B. So a sphere A has some charge. It will have some potential. So a sphere A has suppose potential V1. A sphere B has potential V2. Okay? This has a positive charge. This has negative charge. So V1 will be greater than V2. So initially when isolated, not connected, A has higher potential, B has lower potential. When they will get connected, what will happen? Charge will flow from high to low potential, and they will flow until their potential will become constant. Okay. So final charge, suppose kar lo, at A it is Q1 and at B it is Q2. So finally their potential will become equal. It means K Q1 by potential का formula लिख रही हूँ should be equal to K Q2 by R by 3. So this 3 R will get cancelled, and here you will get what? Here you will get Q1 is equal to 2 Q2. Okay? One relation, but we have to calculate values of Q1 and Q2. So we need another relation. Now you see here, initially this has 12 coulomb, this has minus 3 coulomb, done. And after connection, some charge from this 12 microcoulomb of कैसे, some charge will flow to B, right? So what is happening here actually, अगर मैं इसको system की तरह देखूं तो इस system में initially total charge कितना है? 12 minus 3 microcoulomb, that is 9 microcoulomb. And after connection is made, charge is traveling from one to another, and it's not getting lost to any other system. Done. So still, whatever charge is flown from A is just staying on B. So even now, if I say after connection made and after long time, charge on A plus charge on B must be equal to 9 microcoulomb. ठीक है? Conservation of charge, because this whole system is isolated. It is not connected to any voltage source. They are connected together. So charge will flow from one to another such that total charge of both the bodies will remain same. So Q1 plus Q2 is equal to how much? 9. Now put the values. So this is 3 Q2 equal to 9, Q2 equal to 3, and Q1 equal to how much? 6. So correct answer should be what? It should be D. Okay. Now let's see the forward bias diode connection. मैंने time and again तुम लोग को बोला है, in diode what is important is first identify what is the meaning of this shape. Where is the N side, where is the P side? ठीक है, हमेशा ही याद रखना. ये P side होता है, बड़ा जो side होता है, base होता है, that is P side, and this vertex is your what? N side. And in forward bias, P side is connected to positive terminal, N side is connected to negative terminal. That is, potential of P side is greater with respect to potential of N side. Now see, this is P side, okay? This is N side, and N side has a potential of minus 2 volt, P side has a potential of plus 2 volt. So definitely potential of P side is greater than that of N side. See here, both sides have same potential. It is not forward bias. This has 2 volt, this is 4 volt. So potential of P side is smaller than that of N side. So this is reverse bias. Okay. And here potential of P side is lower than that of N side here also. So this is also reverse bias. And this is not biased at all. And this is forward bias. Okay. So for forward bias, answer will be A. Okay. Chalo. Now there is a string 2 meter long, and this is fixed at its end and is driven by 240 Hertz vibrator. The string vibrates in its third harmonic mode. The speed of the wave and its fundamental frequency is. Okay. So here the string vibrates in its third harmonic. So when it is 2 meter long, it is given here in the question, this is 2 meter long. Okay. And it's driven by 240 Hertz vibrator. 240 Hertz vibrator से ये excite हो रहा है. And in that case, a string vibrates in its third harmonic. What is third harmonic? So if a string is fixed at both ends, in this case, frequencies that you are going to get is, formula is what? NV by 12. So if you're going to put the value of n equal to 1, you will get fundamental frequency, or you call it first harmonic. So for third harmonic, you put n ka value 3. So for third harmonic, we have frequency 240 Hertz. Dekho, in this question, what you need to realize is what is given in the question. A string 2 meter long, fixed at its ends, two ends are fixed, and is driven by 240 Hertz vibrator. So the body that is responsible for vibrating this fixed string has frequency of 240 hertz. And the string, and in this case, a string vibrates in its third harmonic. Yani ki for third harmonic frequency given is how much? 240 hertz. So 240 hertz को आप क्या लिखोगे? 3v by 12. And here 240 equal to 3 by 2 into v. Velocity that we need to calculate. Length is given 2. ठीक है? NV by 2L. Length is 2 meter, right? So this will become 80 and velocity will become 80 into 4, 320 meter per second. Okay, so velocity is how much? 320 meter per second. Now we have to calculate fundamental frequency. So fundamental frequency means n ka value of 1 kar do. So V by 12, that is 320 by 2 into 2. So this is 80 hertz. So correct answer will be what? B. Now you may be thinking why I included this question. So what happens? We generally forget the formula. So for strings fixed at two ends, formula, whatever I wrote, if you have forgotten, suppose, so what you will do, if it is fixed at two ends, so whatever is fixed will be known always. So here amplitude will be 0 always. So first harmonic diagram will look like this. Okay. Second harmonic diagram will look like this. ठीक है, क्योंकि ये दोनों फिक्स है. And third harmonic diagram will look like this. यहाँ पे हमेशा ही तुम्हें जीरो डिस्प्लेसमेंट देना है एंड्स पे, क्योंकि एंड्स तुम्हारा क्या है? फिक्स है. Now why I have drawn this, you can reach to the formula from here. See here, this is L length. A string is same in all the case, so length is L. Okay, and here L will be equal to how much? L will be equal to, this is equal to, in a wave, if you see, this is the wave, then this is lambda by 2, this is lambda by 2, and whole is lambda. So this is lambda by 2. Lambda by 2 L. Okay, and what is the relation between velocity of wave and frequency and wavelength? So V by lambda is equal to frequency. So lambda can be written as what? V by F. So if you see here, L equal to मैं क्या लिखूंगी? V by 2F L. So F को अगर मैं लिखने की कोशिश करूं, sorry, यहाँ पे L मैंने कैसे लिखा? This is L lambda by 2. Done. So V something like that. F equal to, if you are going to write, it will become V by 12. So first frequency मिल गया V by 12. F1. Now in this case, what will happen? Some other frequency of wave is getting excited. And here you can see this is one wavelength. This is, sorry, this is half wavelength. This is half. This whole is equal to one wavelength. So lambda dash another wavelength. Lambda dash is equal to L. Lambda dash को क्या लिख सकते हो? V by F dash. And this is equal to L. So F dash is equal to what? V by L. Second frequency. So on third frequency, you can calculate. So if you have forgotten the formula, you can go like this, but you should not forget the formula. Okay. Now let's move on to this question. The figure shows the path of a positively charged particle, 1. So 1 is the trajectory of positive charge particle through a rectangular region of uniform electric field. Electric field is there. Okay. Direction is not given, so I can't draw it like this anyway. So electric field is there present in this rectangular region. And the first particle is what? That is a positively charged. And when this positively charged particle is entering inside this region of electric field, it has tendency to go up. Okay. So what is the direction of electric field and the direction of particles 2, 3, 4? Okay. First thing, I have told time and again in the class that on positive charge, electric field applies force in its direction. And on negative charge, force will act in direction opposite to the electric field. So outside electric field, there was a positive charge. It is going in a straight line. Done. And if there is an electric field present in this region, and because of that, if particle has tendency to go up, it means electric field is present in upward direction. You know? Because on positive charge, force, electric force acts in the direction of electric field. So if there is no electric field, it will go on like this. If it is also going somewhat up, So upward velocity it will get because of electric force only. So force is acting in the upward direction. And since this is a positive charge, electric field is also in the upward direction. So electric field का direction क्या हो गया? Top. ठीक है? Now let's see particle 2. Particle 2 is a negative. So on it, force will act opposite to the electric field. So 2 पे force किधर लगेगा? Down. Come to 3. 3 is a positive charge. On it, force will act in upward direction because electric field direction is in top. So 3 will have tendency to go to the top, that is up. And 4 is a negative charge. It will experience force opposite to the direction of electric field, that is bottom. Okay? So 4 will go down. Top, down, top, down. So top, down, top, down. This is the correct answer, right? So A is your correct answer. Only thing you need to remember is on positive charge, force act in the direction of electric field, and on negative charge, force act opposite to the direction of electric field. I have explained the reason very much extensively in classes. Okay. Now let's solve this question. There is a circular disc A of radius R and it is made from an iron plate. So there are two discs. ठीक है? पहले डिस्क का रेडियस क्या दिया हुआ है? Its radius is R and its radius is 4R. Its thickness is T and its thickness is how much? T by 4. The relation between moment of inertia. Now moment of inertia for disc का formula is what? Is mr square. ठीक है? ठीक है, done. Now here, circular made from an iron plate. So in both cases, they are made from an iron plate. And it means they are made from material whose density is same. So rho will be same for both the things. So this is rho and its also density is rho. What will be the mass of this disk? So disk area is how much? Pi r square. Done. And its thickness is how much? T. So any disk is like a cylinder. If thickness is very small, we neglect that thickness and we call it disk. Otherwise, it's a cylinder, right? But to calculate its mass, if disk has a thickness T, then we will see it like a cylinder for calculating mass. And mass of first particle, I would say, M1, will be equal to how much? Density rho into volume. Volume is how much? Volume of cylinder, area of cross section, pi r square into length, that is thickness here, T. Just imagine coin, 5 rupees coin that is more thicker. This is also a disc. And 1 rupees coin less thicker. So its mass is this, M2 mass, it will be rho into pi 4r ka square, that is pi r square into 16 into T by 4. So this is 4 times this. So this mass is 4m1. You know? Now let's calculate their moment of inertia. So for 1, it will be m ka value is m1, r is r, m1 r square. And what will be I2? I2 is 4m1 into r का वैल्यू क्या लिखोगे 4r, so 16r square. Am I correct? Yes. Okay. So definitely this is A, this is termed A, this is B. So IA, this is A and this is B. So IA is what? Less than IB. So correct answer will be what? It will be C. Okay. Chalo. Now let's move on to this question. There is a light ray and that falls on a rectangular slab as shown. The index of refraction of the glass, if total internal reflection is to occur at the vertical face. Okay. So here what you desire to have internal reflection at this point. Then it is asked that what will be the refractive index of glass. So first write the equation here. If this angle is R, suppose, so this here draw the normal and this is like this. So this is R, this is 90 degree. This angle will become how much? 90 minus R. So angle of incidence for at point A is how much? Angle of incidence 90 minus R. And let's say this is B. So at B, if I apply Snell's law, B point पे अगर apply करूँगी, I will write sine 45 into 1 will be equal to sine R into mu. Mu is refractive index of glass. So Sin r is equal to how much? 1 by root 2 v. Done. Now let's write the equation, a Snell's law equation at point A. So at A, what is happening? Total internal reflection, and here angle of incidence should be such that at least to that level, so that it can graze, refracted light can graze the surface. Okay. So for critical angle, we will solve this question. Done. So suppose Karlo, for critical angle, this is and this angle is how much? 90 minus r. So mu into sine 90 minus r. And if I'm assuming this as a critical angle, then angle of refraction will become equal to 90 degree. This into 1. Okay. So for critical angle, we will solve it. And क्योंकि if total internal reflection has to happen, this angle should be at least equal to critical angle. Can be greater than that, but at least equal to this. So for minimum case, we are going. Okay. Now we need to calculate mu, right? So if you further solve this equation, mu cos r is equal to 1. So cos r is equal to how much? 1 by how much? Mu. Can we calculate cos r in terms of mu? Because here sin r is given. Then, and cos r we can write as 1 minus sin square r ka root over. You know, we can do that. So 1 minus 1 by 2 u square ka root over. Cos r is like that. Now you do one thing, square it and also square it in this equation. So cos square r. So cos square r will be equal to 1 minus 1 by 2u square equal to 1 by u square. Now we can easily solve it, right? So this will become 1 equal to 2 you write here. So this is 3 by 2 u square. Done. Sorry. Be careful. U square is at the bottom. Done. So u square is equal to 3 by 2. And u will become equal to how much? Root under 3 by 2. So correct answer is what? A. Okay. Now, this is a very important question. On a temperature scale X, the boiling point of water is this. Freezing point is this. Assume that X scale is linear. The equivalent temperature corresponding to minus 95 degree X on the Fahrenheit scale will be. So basically, we have to convert a value on X scale to value on Fahrenheit scale. And how we achieve conversion? This is the important concept here. Then, if you know this concept, because formula alone won't help you. Formula we already know from converting Celsius to Fahrenheit, Fahrenheit to Kelvin. We have formula. But what if a scale is something out of our zone, like your X scale is given? What is important? Whatever scale is there, you just need to know two things. First is your boiling point, then is your freezing point. That is melting point. Okay, melting point. Suppose this is scale A and this is scale B. And here also you know the boiling point, you know the melting point. And suppose here value given is X. On scale a temperature value is X. We are asked to convert this X on temperature, like what this X would read on a scale B. Done. So if we have to convert X to scale B, to values in scale B, how we will do that? So देखो formula ये ऐसे करते हैं हम लोग. X को लिख लो, X minus melting point in scale A divided by boiling point of A minus boiling point, melting point of A. Equate it to, suppose कर लो, X का corresponding value on scale B is Y, suppose. So equal to again y minus boiling point of B divided by boiling point of B minus melting point of. This is how we convert things. Okay. So this is the way. Now in our question, this is a scale X and here boiling point is how much? 65 degree X. Melting point is how much? Minus 15 degree X. This is a Fahrenheit scale. So in Fahrenheit scale, boiling point कितना होता है? 212 Fahrenheit, है ना? And melting point कितना होता है? 32 degree Fahrenheit. So we know this. And on x scale, value is how much? Minus 95 degree x. So what will be its value? Y. Put the values here. So x is how much? Minus 95. Melting point of x scale was how much? Minus 50. And this is equal to how much? Boiling point of A, that is 65 minus, again sign को सही से लिखना, equal to this. Converting y value है suppose. This is 32 in another scale, and this is 212 minus 32. What answers you are going to get? Minus 95 plus 15. This will give us minus 80. And here 65 plus 15. This is 80. And this is y minus 32, and this is 180, right? So this got cancelled. Y minus 32 is equal to minus 180, and y is equal to minus 180 plus 32. Done. And this will be equal to minus 148 degree Fahrenheit. So if a temperature has a value of minus 95 degree on x scale, that is minus 95 degree x, that in Fahrenheit scale will read as minus 148 degree Fahrenheit. Okay. So that is how we achieve it. Now, when the RMS voltage VL, VC, and VR are measured respectively across the inductor, so VL, VC, VR का ratio दिया हुआ है 1:2:3. RMS voltage of the AC source is 100. Then VR is close to what? So RMS voltage is how much? 100 volt. So 100 volt, this 100 volt will drop on inductor, capacitor, resistor. How we add these voltage? Again, in previous lecture also I have included this question because this is important. हर time आता है, ठीक है? So if this is the voltage here is 100 volt, and it will drop on R, it will drop on L, it will drop on C. So VR, VL, VC won't get added scalarly. Trigger warning here. Not trigger warning, sorry. There is a causes point here. Like you should be careful what we do. Like in electricity, we are in habit of adding voltage like a scalar quantity, but this is a AC thing. Uh, it should get added vectorially. And how we add it? VR ka square plus VL minus, yeah, VC minus VL, whatever you do here. Okay, this is square, so it won't matter. Then ideally we do VC minus VL. So this will be equal to V. Now VR is close to, we have to calculate VR. So suppose kar lo 1:2:3 is the ratio. So let's say VL is equal to X. So if VL is equal to X, VC will become 2X and VR will become 3X. And if we are going to put the values, V is 100 and this is equal to VR ka square, that is 9X ka square, plus VC minus VL, 2X minus X ka square, X square, 10X square. Square कर दो आप दोनों side. So we will get it like 10 to the power 4 is equal to 10x square. So 110 will get cancelled, 3 will remain here. So x equal to 10 root 10. Okay. So VR will be equal to how much? 330 root 10. And root 10, 3.1 almost. So this will be close to what? This will be close to not 100 volt, it will be close to 90. Okay. Done. So this will be your answer. Okay, so this is again an important question because this question we can easily solve by comparing gravitational thing with electrostatic. Okay, so electric field is also a conservative field and gravitational field is also a conservative field. So formula will apply at both places. Which formula I'm talking about? Here gravitational field is given. Suppose this is electric field and we have to say change in gravitational potential energy of particle of mass 1 kg when it is taken from the origin to a point 7 meter minus 3 meter. Okay. So initially particle is at 0, 0. Okay. And it is being taken to which point? 7 meter minus 3 meter. So suppose कर लो, here potential is V1, here potential is V2. So suppose then potential difference will be V2 minus V1, and potential energy will become what? Like in case of charge, we study work done per unit charge is equal to potential difference. So work done is equal to potential difference into charge. Done. And that work done is getting stored in the form of potential energy. So potential energy difference will be taken as Q delta V. Same thing we can translate to gravity. Gravity. Okay. In gravity, Q will get replaced by mass. Okay. Only difference. Now let's see. So field is given and the potential difference we have to calculate. You already know that dV equal to what we used to write, minus E dot dr, we write in case of electrostat. So here we can write dV equal to minus G dot dr. We can do it. ठीक है. So यहाँ पे dV को आप लिखो, माइनस साइन यहाँ दे दो, G का वैल्यू लिख लो 5 I cap प्लस 12 J cap. dr को क्या लिखोगे? डॉट dx I cap plus dy j cap. Now we need to do the dot product. I cap dot I cap 1, I dot j cap 0. So dv will be equal to minus of 5 I cap dot dx I cap. It will become 5 dx. 5 I cap dot dy j cap, that will become 0. So उसको मैं नहीं लिख रही, plus 12 j cap dot dx I cap 0. 12 j cap dot dy j cap, that will become 12 what dy. Okay, so this is this done. Now this is this, we have to calculate what? Dv. So differentiate, integrate it. If you're going to integrate it, this will become dv ka integration minus 5 dx. So x is varying from where to where? We are taking particle from origin to 7 meter minus 3 meter. So initially x is 0, finally x is 7. So here you will write 0 to 7 minus 5, minus not 5, this is 12, right? So minus 12 dy. And y is varying from where to where? 0 to minus 3. So here write 0 to minus 3. Do it. V equal to minus 5 dx का इंटीग्रेशन क्या होगा? x. So 7 minus 0 minus 12, and this will become minus 3 minus 0. So this is equal to minus 35, and this is equal to how much? This will become equal to plus 36. So potential difference, if you see, will be equal to 1 unit. Okay, so this is 1, and mass is how much? 1 kg. So potential energy will be 1 kg into 1. So 1 joule. Okay, so correct answer will be D. Now see how easy this question became. So always there is a parallel between electrostat and gravitation, and that parallel you can apply. Okay, so there is a galvanometer coil and it has a resistance of 15 ohm and give full scale deflection for a current of 4 milliampere. To convert it to an ammeter of range 0 to 6 ampere, what we need to do? Again, be careful with its reading, like how you read question of ammeter. Done. So a galvanometer coil has a resistance of 15 ohm. So 15 ohm is what? Resistance of galvanometer, and that is written as RG, 15 ohm. And it gives full scale deflection for a current of 4 milliampere. Yani ki full scale deflection current is 4 milliampere. That is how we draw it. This is galvanometer. Ammeter looks like what? This is shunt. This is shunt, right? This is ammeter. Done. So this is RS. This is RG. And this will get connected to outside circuit for calculating or for measuring how much current is flowing in that circuit. So how much maximum current it can measure will depend on, like suppose karo maximum current it can measure is I. So that I you have to write where? That is important here. So that maximum current which it can measure will try to enter it. So this is I. Now this will get divided into this and this. And along G, how much current will go? It can only take current up to full scale deflection value. Current that is required to fully deflect it. Okay, so that current is 4 milliampere here. So if this is I, here it will come 4 milliampere along this, and here it will go I minus 4 milliampere. ठीक है. So इसको अगर I milliampere में नहीं है, you need to convert 4 milliampere into ampere. Done. And after that, if you have to calculate any of this, what thing you can use? Across shunt, whatever voltage will be, across galvanometer, same voltage will be because they are in parallel. So what you will write now? You will write I minus Ig into Rs will be equal to Ig into Rg. ठीक है. Now put the value here. So I maximum current that it can measure कितना 0 से 6. So 6 है. 6 ampere minus Ig is how much? 4 into 10 to the power minus 3. ठीक है. Rs is how much? We don't know. We need to calculate. Ig is 4 into 10 to the power minus 3 into 15. ठीक है. So this will become how much? अगेन इसको तुम माइनस कर दो. अगर ज्यादा डिफिकल्टी होती है, सिंपली राइट द थिंग. So this is 0.004, 0.004. So this will become how much? This will become 5.996. So this is 5.996 into Rs, and this will become 6 into 10 to the power minus 2. So Rs will be equal to how much? 6 into 10 to the power minus 2 divided by 5.996. So this is almost equal to 6, 5.996, and this is 6. So this will become almost 1, and that is 10 to the power minus 2 ohm approximately. Okay. And this is equal to how much? Milliohm. So we can convert it into milliohm by multiplying it with 10 to the power 3 milliohm. So this is equal to 10 milliohm. Again, so 10 milliohm resistance to be connected in parallel to the galvanometer. Obviously, this is a meter, then shunt will be in parallel, not in series. That happens in voltmeter. Okay. Now this is magnifying power of a telescope is 9. Now for telescope, magnifying power 9 means focal length of its objective by focal length of its eyepiece is equal to 9. When it is adjusted for parallel range, now draw it. This is objective, this is eyepiece, and it is adjusted for parallel range. It means light is coming from the infinity. Parallel range means light coming from infinity. So it will bend at focus of objective. So this is F0. And the eyepiece is found, the distance between objective and eyepiece is found to be 20 centimeter. This distance is given here. This is 20 centimeter. The focal length of lenses. Now, if this is F0, this will be Fe. Why? Because we know that final image we also will get formed at infinity, as we have learned in telescope. So this is Fe, and F0 plus Fe is given in your question, that is equal to 20 centimeter. Okay. So we have to calculate F0 and Fe. We can do it very easily, right? So you do one thing, add 1 to the first equation. So if I'm going to add 1 on the both side of first equation, this will become, sorry, this is Fe. F0 plus Fe by Fe equal to 10. And this is 20, right? So Fe will become 2 centimeter. And if Fe is 2 centimeter, F0 will be 9 into 2, that is 18 centimeter. So correct answer is 18 centimeter and 2 centimeter. Okay. Just from the formula. Now this is another question. There is a block of mass m that is kept on a platform which starts from rest with constant acceleration g by 2 upward as shown in figure. Work done by normal reaction on block in time t is. So work done by normal reaction. So work done is what? F dot ds. So we need to see first how much displacement it will go in time t. What will be the direction of what will be the angle between force and displacement, and what will be force. Done. So let's see here. This is the block, right? So on this block of mass m, mg will act downward, and normal reaction on it will act in the upward direction. And since it is going up with acceleration a, net force will be in upward direction. N minus mg will be equal to mg by 2, mass into acceleration. So m is equal to 3 mg by 2. So work done by normal reaction ही हमें निकालना है. So force value we are having 3 mg by 2. Now normal reaction is acting in this direction. Displacement is also happening in the upward direction. Both are in upward direction. So angle here theta is 0 degree. So this will become f ds cos 0. Done. So this is f ds. Now force will also not change with the time. It will remain constant 3 mg by 2. Because mass is not going to change, g is not going to change. So this is 3 mg by 2. Now we need to calculate displacement. So use the equation of motion. S equal to हम क्या लिखते हैं? ut plus half at square. And it is starting from rest. So u equal to 0 plus half into acceleration g by 2 into t square. So how much displacement? Total displacement value is g by 4 t square. So g by 4 t square. What will be the value? 3m g square t square by 8. So 3m g square t square by 8, this is option D. So this will be your correct answer. Okay, now let's see in this question. What is happening? There is a building and there are 15 bulbs of 45 watt. So there are certain number of bulbs in the building. And how many bulbs? 15 bulbs of 45 watt. Then there are another 15 bulbs, and these another 15 bulbs are how many number? 15, and its power taking capacity is 100 watt. Then in the house, what things are there? 15 small fans. अब मैं फैन कैसे बनाऊं? मैं फैन लिखती हूँ ऐसे, ठीक है? And its number is 15 and it's taking how much power? 10 watt. And then there are two heater, and this is two heater of 1000 watt. Done. And this whole thing is connected to a mains of 220 volt. Done. And it is said that minimum fuse capacity of the building. So यहाँ पे कहीं पे भी fuse लगा होगा. Fuse का काम क्या होगा? If more than required current is coming, it will melt and it will protect all these instruments. That is fans and all. So maximum current that it should deliver to the home should be what? That's the question. So for that we will see how much maximum power home requires. Then suppose karo maximum power that home is getting or is consuming is P suppose. Then, and this is our 220 volt ka main supply. And suppose current going out is I, this is voltage V. So P should be equal to V into I. Then, and whatever I value we will get from here, that will be the minimum fuse capacity. Done. Okay. So let's calculate total power. So what will be the total power? You just do the calculation. 45 into 15. So multiply कर लो. कितना होगा ये? मैं directly यहाँ पे कर रही हूँ. So this will become 675 watt. First हुआ. Second क्या है तुम्हारा? 15 into 100. 1500. Second कितना हुआ? 15 into 10. So 150. और ये कितना हुआ? 2000. This much watt. Again, if you want to calculate it like in a very layman term, then you can simply do it like this. And this is your 1500 plus 150 if you're going to do. So this will become 1650. Okay. And nothing is left now. Okay. So this is 5 and this is 2 and this is 3 and this is 4. Something like that. Okay. Are we correct? Yes, it seems like. So this is your 4325 and this should be equal to 220 into I. Calculating. Sorry. So calculating it, we will get the answer. So I equal to 4325 divided by 220. अब इसको देखो calculate करो. Like 220 into 2 if you are going to 2, then it will become 440 and here it is 432. So very much close to 450. So 1 times में जाएगा and after that whatever will remain will go by 9 times. So are you getting me? So 19 point something. Okay, and that will be close to which 20 amperes. So answer will be what? 20. Now this is the last question that we have to do, and this question is from wave calculation, like how we calculate velocity of wave and things. So this is a very good question actually. So there is a uniform thin rope of length 12 meter. So there is a rope, and this rope is of how much length? 12-meter length, and 6 kg hangs vertically from a rigid support. From a rigid support, and a block of mass 2 kg. So this rod has a mass actually. This is not massless rod. Its mass is how much? 6 kg. And the block of mass 2 kg is attached to its frame. And here also 2 kg is attached. Okay. What is the wavelength of wave train? A transverse short wave train of wavelength 6 centimeter is produced at the lower end of the rope. So at lower end, a wave train of wavelength 6 centimeter is produced. What is the wavelength of the wave when it reaches the top of the rope? So what will be the wavelength when that same wave train which originated here is reaching at this point, at the top? What will be its value? So we just see one thing first. Suppose you have a string, and what is happening through a string, if a wave is traveling, and along the string, what is happening? Velocity of wave is suppose changing. And in that case, what will happen? Frequency of wave will remain same, but its wavelength will also vary. So the whole concept here is कि if a wave is traveling along a rope of different tensions at different points, then velocity will be different. Because velocity of wave on a string is equal to how much? T by root mu. T by mu. Mu is the linear mass density of rod, and T is tension of the rod. So if velocity along rod is going to change, wavelength will change such that frequency of wave will remain the same, because frequency won't change in this scenario. Then that is for a fact. Now, so what we have to do, velocity by wavelength, that is frequency. This is the relation. Frequency will remain constant. At this point, if frequency is f, at this point also frequency will be f. That is, if this is 0.1, this is 0.2, then V1 by lambda 1 should be equal to V2 by lambda 2. Okay? Now, V1 value is how much? That we need to first calculate. So, at this point, tension will be what? So, tension gets determined for such scenario by how much mass is hanging from that point. Done. Because if something is hanging, tension will arise from where? From whatever mass is below it, because that mass, because of gravitational force, will stretch the rod. Done. So below this point, how much mass is there? 2 kg. So this weight of 2 kg mass will try to stretch this point, and that will create tension at this point. So tension at this point will be equal to weight of 2 kg mass. So velocity v1 agar मैं लिखूं, so I will write 20 Newton by mu. Mu is the density of linear density of rod, and that will remain constant throughout because it is given here. This has a mass of 2 kg, sorry 6 kg, and its length is 12 meter. Nothing is given about how the mass is distributed, so we will assume that mass is uniformly distributed. So this is this. V1, lambda 1 value is given 6 centimeter. V2 will become equal to how much? Here tension will be how much? So below 0.2, how much mass is there? So 2 kg this and 6 kg this. So 8 kg mass is there. So weight of 8 kg mass will be equal to tension at 0.2. So right here, 80 by mu. And this is equal to lambda 2. Mu will get cancelled. This is root 20 and this is root 80. Lambda 2 by 6 is going to be root 80 by 20. So if we are going to solve it, it will become lambda 2 will become how much? 6 into root 4, that is 2. So 12 centimeter. So answer will be what? 12 centimeter. I hope it is clear and all the questions that I tried discussing is clear. Done. So Everyone, if you're having any doubt in any other question or in the question that I discussed, somehow you couldn't understand or some concept you found confusing, you can let me know through whoever of our team is in contact with your school. You can send them, and I will be very much happy to send you the solution, okay, of that particular thing. Till then, bye bye. Take care. Stay happy, positive. Keep working. Keep attending tests, and that's all. Take care of your health. Bye bye. Take care.